concepts, how to apply pseudo force, you know it. You can manage most of the things. Okay, look at the how to decide in what direction it will shift, because 3 blocks are there. You do one thing. This cannot determine the motion of the wedge along x-axis. This acting vertically. Let's come for this one. This T and this T. Component of this tension, component. This will cancel out. Component of this tension is there along x-axis. Fine. Then normal contact. And there'll be also normal contact. Wedge may not move also. Some situations. It can happen. We are not very sure. It can happen that also. But in a question, how to decide that what direction it will move? Any direction? Can we make a rule that in any direction we can assume, or any one specific direction? I feel like I felt this is a difficult thing when I read this question. No, I felt this is what the difficulty what I feel, in what direction I should assume. Any arbitrary direction, or no, some specific direction should be determined. No, some specific direction. In previous problem, it was a specific direction. Let me take you back. This one. Here, why can't this move like this here? So here open, there must be a specific direction. You can't put anywhere, because who will determine in what direction should move? This particular block, he has given condition. Based on this open, I assumed it. Agree this? So you have to search for any conditions are available which will make the wedge to move in specific direction. No conditions are there, any arbitrary direction. Fine. So these are some very small basic observations which we have to do it here. Now there'll be normal contact will act here. So let's get into all the forces that are acting first. So there'll be normal contact. So that I'll show it here, N1, this N2, this N2, this N1, and another force, 5 mg sin theta. So look at this tension and N1. So first what will happen? The string will become taut, and here also 5 mg, this will be acting here. So the string will become, the moment I release, here the string will become taut, this will start moving. So this component of tension and N1 will try to make it to move. And so when it starts moving towards right, then it will push the block 8M. Then there'll be normal contact. This idea. So therefore the resultant motion should be towards right here. So for the wedge, A0, I'll write it, or so let it be some symbol. A3 will write it, the acceleration of the wedge. So then they store in contact. So this will have acceleration A3x. A2 will write it. A2x. Then acceleration of this block with respect to wedge, let it be A13. We'll bring pseudo forces, then we'll write all the possible equations, we'll solve it. There's no other way. But sir, how you decide towards right, that is very important. You have to take help of the laws of motion. The moment you release system, 8 mg will act, 5 mg will act. Since this force will be greater than this, strings will be taut. Then because of tension, okay, so look at this T will, horizontal direction will cancel component of this tension. Component of this tension and component of N1 will make the wedge to move towards right. Then it push the block 8M. Then N2 will come. So naturally, the wedge will be moving towards right. The block, this is the motion of the block with respect to ground I described. Then or if you, with respect to wedge, if you want to describe it, then show that pseudo force here. It's left to you. Okay, now this block 5 mg cos of 5 mg sin theta, tension N1 and pseudo force. The pseudo force, we have to show it here. Okay, let's write all the possible equations. First, this 8 mg minus t is equal to 8m a2y. Then n2 is equal to 8m into a2x. This is for block 8m. Then for the wedge, n1 sine theta plus t cos theta minus n2 4m a3. Then for the block along the incline, 5mg sine theta plus t component of pseudo force 5m a3 cos theta. Pseudo force, I'll what it is, pseudo force. Okay, 5m a3 cos theta should be equal to 5m a13 along the incline, perpendicular to incline. N1 5m a3 sine theta can we write any, so many unknowns are there, no? Check it. Tension, we have normal contacts, N2, T, N1, N2, T, A3, A2X, A2Y, and A13. A2X and A3, because as N2 non-zero. Acceleration along common normal. If the two bodies are in contact, acceleration along common normal must be equal. The acceleration of the wedge is A3, acceleration of the block is A2X. So therefore, A2X equal to A3. Only reason they're in contact. The block 8M and the wedge are in contact, and they're having as their normal direction. So acceleration along common normal should be equal. This is the idea. Sir, can I apply here also? Yes, you can apply it. Provided what, you should know what is the acceleration of the block ym with respect to ground. And if you know acceleration of the wedge, then acceleration along common normal must be equal. It's a general rule it is, and very important idea like. So in wedge constraints, these are the two things. One, the change in length of different part of strings, how it is related to displacement of block and wedge. There is the one thing. Next, acceleration along common normal of the contact surfaces must be equal. I think these are the two things are there. I'll write, if you want, I'll write statement or not needed. Okay, fine. These two are in contact. So if you know acceleration of block 5m in objective questions, they'll give acceleration of this 5m, they'll give acceleration of, they'll ask you to calculate the some constraint equation, or I'll give this one. Acceleration, I'll give the angle. Something, I'll ask you to find out acceleration of the wedge. Straight away, acceleration of common normal must be equal. Whatever the other forces, let it be, no problem. See, I'm writing this motion with respect to ground, just for students to, so that they can think, no, this, I wrote motion with respect to ground. If you write motion with respect to wedge, then pseudo force, then this will become N2 minus 8m A2x equals 0. So that students can make observation. That's why I just wrote like this. In ground frame, I wrote it. Otherwise, what will happen? N2 minus 8m A2x equal to 0. This pseudo force you show in this direction. Okay, I do have the equation. No, what to do with this string? I think the string will definitely help us a lot. How to bring constraint relation between A3, A2y, and A13. What is this length? X13, you write it. This length will not change. The length is fixed, no? The distance. And this length is changing. And the wedge is moving. Change in length of this string and this string. This is what with respect to along y-axis, the wedge is not having any motion. One equation is what I brought this one. Let's see anybody constraint equation. A13 is equal to A2y. What is the role of wedge there? Being on wedge frame, you're writing?
Yes, sir. Entire string is on wedge only, no, sir. So wedge will not affect anything.
This change in length of this string will be 0. Change in length of this string is what? Displacement of block with respect to wedge. What about this length? Change in length of block.
Vertical displacement with respect to ground or displacement with respect to wedge? Same.
Wedge is not having motion along y-axis. So you can write A13 is equal to A2y. Along x-axis, we can't write. Okay, now let me write here. X1, okay, I think I cannot write R13. Okay, let me write directly. A13 equal to A2y. The reason for that? By string. With the help of string. Okay, now let's count how many unknowns are there. T, N2, 1, 2, 3, 4, 5. Can we solve? A2y. A2y is equal to, in fact, A13, no? Yeah. And also A3. A2x equal to A3. Okay, how many equations we have? Okay, this one. A2y, I'll write as A13. A2x as A3. 1, 2. Okay, there's one more equation. This one and this one. Yeah, we can solve it. Somebody gave answer. Let me check it. 121 G by 680. 44 G by 205 is given. I'm not sure, like answer given this, we have to verify it. 44 G means 440 by 225 or 44 G by 225. 205, sorry. Verify afterwards. This idea. Okay, let me get into the other thing. There's an answer given in the textbook. Let me take next one. Ninth one. Very nice problem. Once again, the same wedge concepts. Okay, one more thing here. Anybody center of mass? I want to, I like center of mass very much. I'm asking center of mass. regarding center of mass? Will it shift along x-axis? Anybody? Any answers? No, it will not shift. Finish. That's all over. No, write it here. Delta xcm 0. Shall I tell you one thing? You really want to solve center of mass problem, come back to wedge constraint and discuss. You get so many beautiful questions are there. Net force on system along axis will be 0. You see like a t cos theta, t cos theta. Here t cos theta, t cos theta. N1 sin theta, N1 sin theta. N2 and N2. Finish over. And center of mass, in fact, will shift along y-axis. So here in the problem, I may ask you find the acceleration of center of mass. So more than one options. Along with this, I may dump such things for you. You be careful. All wedge constraints, do think about center of mass. Net force on system, what is the reason for that? Okay, I agree this. There's a condition. Again, similar, same. So almost, you know, I think some formulas, what you get, no, better you remember.